Okay, we're going to find the inverse of the following matrices. We're going to use the calculator to do so. Remember, the first step is to augment it with the same size identity matrix. And our goal is to get the identity matrix on the left, and if we can, the inverse will appear on the right. All right, and again, we're going to do this via the calculator, which makes our life a little bit easier. There's a bunch of ways to get a 1 in the top left, but let's just go direct because we're going to use our calculator. So let's multiply the first row by a half. And then assuming that that is a 1 there in the 1, 1 entry, we'll say -6 times the first row. Add it to the second row, makes the second row. So we'll go in, second matrix. I'm going to edit matrix A again. We'll make a 2 by 4. Put all that information in. And most importantly, double check it before you start, because one digit off, there goes the whole thing. All right, I'm going to quit out of here. Second matrix, scroll over to math. The first one is a star row. And the second one is a star row plus. If you don't know what I'm doing, please watch the Gauss-Jordan videos so you can see what all of these star row things do, star row pluses I should say. It was an award-winning video. Okay. And then because we got some decimals, let's make it prettier and have it say convert to fraction at the end there. Great. Our first column is done. We move on to the second column. Where that -3 is at, namely this one, we need a 1. And where that 1 above it is at, we need a 0. So let's take care of the -3 first. We can say -1/3. Row 2 becomes row 2. And then assuming that's a 1, we can say -row 2 plus row 1 becomes row 1. So we got another star row and then a star row plus. That sound you hear is not a ghost. It is my dog chewing on a rubber bone because he is very destructive. And it's not my shoes. And he's happy as a clam right now. And one more time, math, convert to fraction. So we were able to get the inverse on the left, which is, we were able to get the identity matrix on the left, which means that the inverse is what I'm writing right now, appears on the right. So the inverse to 2, 2, 6, 3 is -1/2, 1/3, 1, -1/3. In part B, we're going to do the exact same thing. We're going to augment it with the same size. Let me pick a different color. Is purple okay? I hope so. Same size identity matrix. So in this case, a 3 by 3 identity matrix is a huge gap there. Sorry about that. We already have a 1 in the 1, 1 position, so we need to make some zeros. We can say -2 row 1 plus row 2 makes row 2, and -3 row 1 plus row 3 makes row 3. Okay, at this point, you should be very, very comfortable with Gauss-Jordan, and more importantly, with putting things into the calculator. So pause the video and make sure you can get everything in there just fine. So try those two operations. So if you look on my computer calculator screen there, you should see the two operations and then the result there. We don't need to convert to a fraction because everything's a nice and pretty decimal. So let me copy that real quick. If you already have this copied down, think about what the next operations are going to be to clear out that second column. We already have a 1 in the 2, 2 position, so we need to make this 2 and this 4 both 0. Using that 1, we can say -2 row 2 plus row 1 makes row 1, and -4 row 2 plus row 3 makes row 3. So again, those are both star row plus commands. Again, pause the video, see what you can do. You will see the result on the calculator right there. I'm going to move this over. Sorry about that. Let me copy this down. And again, if you already have that copied down, great. Think about, we only have one more operation actually. So think about that last operation. Hopefully you're not saying the last operation is calf implants. Don't do it. All right, where this -1 is at, we need a 0. We already have a 1 in the 3, 3 position. So if we just say row 3 plus row 1 makes the new row 1, that would be great. Since we're just adding here without having to multiply, you might be able to just do that part in your head. So 5 plus 5 makes 10. -4 and -2 make -6. And 1 plus 0 makes 1. So that means the inverse of that matrix is 10, -6, 1, -2, 1, 0, 5, -4, 1. Remember, you can check this by taking the original matrix and multiplying by the inverse. So if we call the original matrix A and multiply it by A inverse, if you multiply them in both directions, you should always get, in this case, the 3 by 3 identity matrix. And for part A, same deal, multiply the answer and the original in both directions. You should there get the 2 by 2 identity matrix.